Now in the last video I had left you all with a cliffhanger, right? That will this program compile or not? So let's hit compile, and what does it say? Error expected declaration specifiers before string constant. So your code or the compiler is expecting a declaration. Now what is a declaration, as you may ask? Now go back to the previous video, probably in the last 5 minutes, where I defined a function, right? A function takes in an input, gives a desired output in maths, and in computer science a function may or may not have an input and it does a predefined task. Now the word predefined here is of utmost importance. Now where is the definition of printf? Now don't confuse yourself with this word called definition. Okay, it is not a science or a biology or a chemistry class where I'm asking you definitions that define an atom, define a cell, right? The word definition in computer science means that what does it do? Like printf will print us this number 1 on the screen, we know it, but how does it do it? So printf must also have some code written inside printf function, right, which is available to use to us. So those predefined sequence of code which defines the behavior of this function, do we have that in our code? The answer is no. So we must have a behavior definition of this printf, that how will this function behave, how will this function act, and how will this function do the task that we are giving to it, right? So this function or the code written in, or the code that defines what this function will do, is written in some other file. Like for example, we are writing our code in the file called, here it is, test.c, right? So this is our code, but at the same time we are also using a pre-existing or a predefined code, which is the code for printf, right? Now if we don't include that in our file, how will the compiler understand that what it is supposed to do when it encounters this word, right? So I'll tell you which file to include, and the name of that file is standard input output. Okay, hash include, or include and hash we have to add in front. Now you see, just when I add the hash character before this line, it changes, the color changes to green. Now the color has nothing to do with programming. Okay, let me make this very clear. You may write code in a black and white text environment, it will still work. The colors like this blue for 1, red for parentheses, and this entire line turned green after I put hash in front of it, it is just for aesthetics. It is just for you to differentiate between different types of statements written in your code. Like for example, this hash, This symbol hash is giving a direction to the compiler that before you do any task, before you start to read the code written in test.c file, what I want you to do is that you include this file, standard input output file. Now you will see that I only selected the name and not the extension. Now some of you may know, some of you may not know. So I'll assume that we are all beginners, right, who are watching this video. So when you click a photo on your camera, you must have seen .jpg or .jpeg at the end of the file name specified by you, right? So JPG is an image encoding format. I'm sure everybody of us knows that. Similarly, when you listen to a song on your music player or your computer, mostly probably you will use the encoding format of .mp3 or .aac, right? Similarly, when you write a text file, you use .txt. When you use an MS Word file, you use .doc or .docx, right? For Excel, it is XLS, right? So when you're writing a C code, the extension of this file is .c. The name and the extension makes the file name. Similarly, this H signifies header file. Now what is a header? That is a bit advanced concept for you to grasp or to understand fully right now. So just make sure, I'll give you a very crude example, that this file contains definitions and behavior for many functions which are already written, already available for you to freely use it as and when you require. Let's keep it at that at this moment. Now for printf, the printf's definition or its behavior or how will it print the number 1 on the screen is written inside this file stdio.h, this file that I am selecting right now. And we are telling the compiler that before you read my code, you bring stdio.h and paste it in my file above my code, okay? And to bring that stdio.h, the command used is include, and hash signifies that this is a preprocessor. Now processing means to read the code line by line, right? And I've already told you that before the compiler wishes or tries to read my code, it should bring in some other code and then merge them together and compile them together. All right, so now let's hit compile again and see what happens. Did this error go? No, it still remains. Now comes another concept called the main function. All right, now what is a main function? When you go to a restaurant, or for example you go to a power plant or some office, there is a manager, right? The power plant manager, the electric plant manager, the project manager, or the principal of your school, or the manager of a restaurant, right? What does it do? What does the manager do? The answer is it delegates jobs, or it delegates the today's job that the other employees are going to do, right? So when the main function is treated here as a manager. When I write main here and enclose my code inside parentheses, it means that main is calling or using or delegating the job of printing 1 on the screen to the function printf. Manager mostly delegates the job, it guides, it tells what to do. Okay, now we will maintain this structure religiously throughout this course. We will make sure to write code in a structure where the manager or the main function delegates job or jobs to different function or functions and keep the main function as light as possible. Okay, and the second reason to include a main function in your program is to tell the compiler where to start reading the code. Okay, now when I use the word code, what does the word code mean? In this subject, the word code means an instruction, a direction that you want to give to the compiler. Now the direction that I want to give the compiler right now is to print 1 using the printf function or taking the help from printf function. But at the same time, someone has to tell printf that you have to do this job, right? And who will do that task of delegating the job? The manager. And in C programming language, the manager is termed as the main function. It is where the program starts. If this thing is crystal clear, only then you should proceed, or you should just use the technology available to you to rewind this video and listen to it until it is crystal clear to you. Now once again, the main function will be the manager. It will delegate the task to other functions. Now main itself also is a function, it is a special function. Like for example, a manager is also an employee of the company. Be very sure about this fact. We are all employees of the company, but manager is also an employee. Manager has a special power. The special power is that it will delegate tasks. Alright. Now the compiler will call the main function and the program will start compiling from there. Now how does a compiler do that, and what capabilities does the compiler have? That are advanced topics. We will definitely address them, but not right now. Now let's compile the code. Processing C file, warnings 0, compilation time 1.6 seconds, and we have an output file called text.exe. The exe is called executable, right? So let's run this code. After we have compiled it, we will run the code, and there it is. We get 1 on the screen. So is our task done? Obviously not. We have to print till 10, right? So as we all know, we are well aware of the greatest invention of mankind, which is the copy paste. Let's print 2 here, let's print 3 here, let's print 4 here, and let me change the example. Let me print till 5. Okay, is our task done? I told you that we need to print from 1 to 10, but this is a monotonous task, right? If we can do it for 5, then we can obviously do it for 10. We just have to paste this code 5 more times, or we can select this entire code and paste it, copy it and paste it once, and then this is 6, this is 7, this is 8, this is 9, and this is finally 10. Okay, so is our task done? Of course it is. Compile it, no errors, no warnings, run it, and you see 1 2 3 4 5 6 7 8 9 10. Now something wrong is there, right? Can you see what's wrong here? This number looks like a single mathematical number, right? A single mathematical entity. Now it may be some 123 crore 45 lakh or something, I don't know. It is a too large number for me to to read in English, right? The number is 1 2 3 4 5 6 7 8 9 1 0. Is that the number we wanted to print? No, we wanted to print 1 to 10 as 10 different entities, not a single entity. So what we will do is that we have to insert a new line after every numeral, right? So we use the character backslash with n. N stands for new line, right? New line. And let's keep the example short. So I am removing this piece of code, saving it, compiling it, no errors, no warnings. I'll run it. There it is, 1 2 3 4 5. I have shortened the example. Now if you show this code to your HOD or your subject teacher or your senior or your project manager, you are going to be in deep trouble, even though your code is absolutely right. There are no errors, no warnings in this code, right? The compiler does not lie. There it is, 0 warnings. So what's the problem here? The problem is, let's think a little. What if I told you to print up till 1 billion numbers? Would you do the same technique? How many times would you copy paste it? If I told you to write a Google numbers, you know what is a Google, right? Maybe it is a, even I am not sure, so I'll just Google it. Google value. One Google. There it is. It is to the power of 100, and this is where the word Google comes from, right? That it has the power of the exponent to 100. It knows that much. So if I tell you to print a Google numbers on the screen, it will take you maybe your entire lifetime to copy paste this code, right? It will have, you will waste your entire life without eating, without sleeping or doing any other task, and you will just hit Ctrl C, Ctrl V and go on until the day you die. And maybe even that will not be enough. Now what is the way to do this task? As we know, computers were invented to reduce the manual labor, right? So we need to be efficient, and we need to respect this invention, and we need to use it to its full capability. Now how will you do that? So we are going to keep this code as a reminder of what not to do. Not to do. A reminder of what not to do. And we will begin our journey, our odyssey of coding from this line number 11. Now the problem statement still remains. We found a solution. It is a laborious task. It feels like it's better to take a pen and a piece of paper and jot down from 1 to 10, right? So how to automate this? Now imagine you are walking on the road, right? Now instead of a road, replace the road with a number line. Now here comes the important part where I am teaching you how to think. You have to close your eyes, make your mind perfectly clear, and think that you are walking on a straight line. The road is very wide, right? Imagine and make sure that the road is very thin. It's as thin as a line, and you are walking on that straight line. And you begin at the number 1. Okay, you begin at the number 1. So you are standing at 1, you take a step. Where do you reach? You reach 2, right? So here it is. In this code you wrote printf1, you took a step. You wrote printf2, you took a step. You went to printf3, and so on and so forth. And I told you that this is not the right way to do it. But thinking is exactly right. You have to take a step one by one and print up to 10, walk up till 10, and then stop. So what is your job here? Your job is to move from 1 to 10, right? One step at a time. So the action of taking a step, one time you lift your right leg to take a step, and the other time you take a left, and then you repeat this process, right? So walking for 10 steps can be broken down into an action of just one motion, which is lifting your leg, planting your foot down, and then willing yourself, moving yourself with the force exerted by your feet to the floor or the number line, right? And you have to automate that 10 times. So 10 steps. So in programming, or any programming for that matter, if you want to take step and then automate that for, let's say in this example, 10 times, we have a thing called a loop. Now this word you may have heard or you may not have heard. The word loop means repetition, right? So how do we configure our loop? There are 3 kinds of loops in C. We will study all of them in very much detail, but right now my objective is to not bombard you with syntax. My aim is to enable you to think, to feel the power or the ability that a loop can possess or the loop can do for you. Now let's say we have a variable a and we make it equal to 1, and in the comment, which is /, we can write start position. Okay, so variable start instead of a, let's use a proper variable name, as it is a proper and nice way to learn programming, that you should use variables which make sense, not a, b, c, d, x, y, z, right? You should make a variable name which makes sense. So after defining the start variable, we define the end variable as 10. Okay, and then we automate the task by using a loop. Okay, and in loop we will use printf to print the value. Okay, so the start is a boundary, the end is also a boundary, so they are fixed, right? They are stationary, they can't move. So we also need a variable that will move from start to end, right? So let's call that variable step. Okay, so step is equal to start and then a semicolon to signify that this statement has ended. Now we have told one boundary. What's the other boundary? It should not exceed 10, right? So let's do it. Start is less than end. All right, and now comes the third part. What should be the size of your stride? What should be the size of your step? How much do you want to move in one motion? As I told you, if you want to print every number between 1 and 10, your step size should be 1, right? It should not be 2, then you will be going from 1 to 3 to 5, right? You need to move step by step or a singular step at a time. So we will do step is equals to step plus 1. Any problem still here? If there is, you please watch time and again about what I have told you in the past 5 minutes since I have started the automation process, not this static code, right? You please watch. I'm not talking about this code, I'm talking about the code part, not the statically just printing 1 2 3 4 5. No, we are not interested in that. So printf, what do we want to print? We want to print the step, right? Now will this code work? There is only one way to find it out, and that is to compile. Now we have our first error on line number 15, column number 2. File name is test.c. yes, there we are. And the message says error, start undeclared, first use in this function. Now there are more errors, but always make this a practice of fixing one error at a time until and unless you are a medium level programmer. You should not look at any other error apart from the first error. Now I am teaching you not only to think but also to debug the code. The process of removing bugs or unnecessary actions or anomalies from your code is called debugging, right? So here we have our first error which says start undeclared, first use in this function. Now what is a declaration? As I've already told you for the printf example, until we did not include this stdio file, the compiler did not know what to do when it encountered the symbol printf. The definition of printf and its internal procedures and internal steps as to what the printf function will do is written in stdio.h. That much is very clear to us. But they are talking about a variable declaration, not a function declaration here. So how do you declare a variable? It's quite simple. You have to tell the compiler what type the variable is. Okay. So how many types are there? We have the integer. Okay. you should be knowing what are integers. Okay, an integer can be a negative number, a 0, or a positive number. Now, is my definition right? There is a slight problem. Actually, is 2.5 an integer? Surely not, because it's a number, and that's where the problem in my definition lies. So the definition is, an integer is a negative whole number or a positive whole number or a 0. It does not have a fractional part. So we want to start from 1, go to 10, take a step, one step at a time. So all three are integers, right? Int start, int end, and int step. So we have declared all of them. Let's hit compile again. Okay, passing argument 1, printf makes pointer from integer without a cast. Now this error is a bit advanced for you, but it can be easily resolved without knowing actually what this line means. I'm sure, I'm not shying away from explaining you what this means, but this is just the second video. Please be very patient and try to absorb as much as I'm trying to convey to you. Now, when I told you what printf means, it means print, and then this singular f means format. Now what this warning is trying to tell you is that you have not specified what is the format you want while you use the variable step. Alright, the formatting is very important for the compiler to know as to how to treat that variable. Now, as we have defined here step, we have defined it as an integer, right? So what is the formatting of an integer? How do you print an integer? So the formatting used is in double inverted commas %d. The letter D stands for digit, and also you can also use this format specifier called %i. I stands for integer. So these two can be used, and we will obviously provide the formatting for our variable step, and we use the punctuation comma to separate our arguments, our parameters to the function. As I've already told you what is a parameter of a function. If you want to calculate the value of sine 30, there sine 30, or I mean 30 degrees, is the parameter to the sine function. Here we have two parameters. One is the format, like %d, like see, when you, this is the beauty of this IDE, when you are in a function in the parentheses, it tells you precisely what the printf demands from you. There it is, constant character star format, and then you see an ellipsis, which are 3 dots. These 3 dots at the end is called ellipsis, which means you can have n number of parameters. Right now we have only one parameter to be printed, and whose format, the constant char star. Now we don't be very ingrained or very much bothered with the big red things that they have written, like const, char, what is a asterisk doing over there, what are underscores doing there, what is a restrict, what is a format with a capital F. These things will make you go dizzy if you pay attention to them right now. Okay, I am here to make things easier, make things legible for you. Okay, so we will use a format. Definitely the format is a digit, and who do you want to format? You want to format the variable called step. Now this much should be perfectly clear. If it's not clear, I pray to you, I request you to watch it again and again until it is crystal clear to you. Now we hit compile again, and there you have it. You have no warnings, no errors. You have an output called test.exe. Now let's run the code. There is the problem. It is giving, you must have seen the movie called Matrix, right? An infinite loop has occurred. So what's the problem here? Did you guys notice the problem? Now the problem is very simple. There is a problem in this statement over here. Now let's look at the for loop perfectly. Okay, the first part of the for loop is called it is not a hard and fast rule. It is a convention, right? The convention is that you initialize the variable that you want to use as the loop variable in the first part. In the second part, you put some condition on that loop variable, and in the third part you put how do you want to change that variable. All right, so the first part says that I want my steps to start from the milestone 1. I told you to keep that example in mind, where you close your eyes and imagine that you are walking on a number line from 1 to 10. Okay, so here we have it. The step starts from the boundary called start, and the value of the variable start is 1. Now here, when we have to do the condition as to till where our variable will go, instead of using the start variable, we should use the step variable. I hope you understand why that is a mistake, and if you don't, I'll explain it to you in a very simple manner, and that is, you want to stop somewhere, right? And your variable name that you want to stop or you halt is step variable. So this variable should be less than end. Instead of comparing start with end, we need to compare step with end. All right, and our step size is 1 at a time. So let's recompile the code. Again, we have no errors. So the last time when we compiled the code, we had no errors, right? But did the code work? Absolutely not. And that's where most beginners have the problem, that they say, sir, my code is right, it has no errors, no warnings, then why doesn't my code do what I want it to do? And that is a question that many of us have, and the answer is very simple. The program should be correct according to the C programming rules, but at the same time it should make logical sense. In the previous version of the code, I had used the variable start instead of end. Now will the start variable move? Is it mobile? No. The step variable is mobile. The step variable must move, and hence the comparison must be done with the step variable. All right, so we have the initialization, the test/halt condition, and we have the change. All right, how do you want to change your step? I want my step to be in the order of 1. All right, so we have compiled it already. Let's run the code. Now we have the earlier error. The error is that they are printing side by side without any space or without any change in the line. So it looks like a 9-digit number instead of 9 different numbers. So we already know how to do that, which is use the \n, which signifies a new line. Let's recompile it and run it. So is our problem solved? The answer is no. Why? Because our problem, our initial problem, is to print from 1 to 10, not till 9. And here again the loop control has the answers to your problems. Now initialization is okay, right? It starts from 1, there is no trouble in that, but it is going until 9. But here you have written it 10. So why does it stop? Just 1 less than my boundary. And this is where mathematics comes in. Let me ask you a question. Is 4 less than 5? You will say yes, it is. Now if I ask you, is 5 less than 5? The answer is no. Now let's combine some other symbols with it. Okay, if I ask you, is 5 less than equal to 5? Now comes a tricky question. This symbol means less than or equal to. Let's write it down. Less than or equal to, equals or equal to, whatever you want to pronounce it as or write it as, right? So is 5 less than 5? Answer is no. But is 5 equal to 5? The answer is yes. And the connective or signifies that if one condition is true, or if one condition satisfies, then the condition is true, right? Let me take an example. Do you want to eat or drink? So if you say I want neither, so you will be given neither to drink nor to eat, right? But the question was, if somebody asks you, you can either eat or drink, so there is a choice, right? So you can either select less than or you can select equals to. So that same logic is applied here too. So the question, is 5 less than equals to 5, can be broken into two atomic questions, which is 5 less than 5? And the second question is 5 equal to 5? The first answer is no, and the second answer is yes, right? So this is the difference between less than sign and the less than equal to sign. So here, if we find out how this code actually works, or how the C compiler interprets or understands this code, we will be able to find the exact position where our code is malfunctioning, right? Our code is malfunctioning, right? Because we want to print it till 10, including 10, not just till 9. So when you are taking steps from 1 to 2, 2 to 3, 4 and so on, the value of step will get increased one by one, right? As we have already seen in that output screen. Now what happens is that when it reaches the value 9, at that time the compiler makes this calculation, is 9 less than 10? And the answer is yes, it is less than 10. And then the program flow enters the printf, it enters the loop, and once it enters the loop, it prints the value 9, it comes out of the loop and re-enters the loop. Alright, when it re-enters the loop, it increments the value of step to, you guessed it right, 10, and again it asks the question, is step less than 10? Now I have already explained to you that the answer to this question is no. And since the answer to this question is no, the printf does not execute and we do not print the value 10 on the screen. And you might have guessed it, what the solution is. It is to give an equal to sign over here. So our termination or the halt or the test condition is step less than or equals to end. Right? Now let's compile it. Let's run it. There you have it. Perfect, right? Now does it seem like magic anymore? So this is what my aim is, to simply not write a code. I could have simply opened this text editor and named the title of this video as printing from 1 to 10, and here is the 5 lines of code. Happy coding. The video would have been 6 minutes long, right? And now it is around 47 minutes long. And that's the difference. Now it may seem very monotonous for people who have some prior programming experience. So I implore you, I request you to watch from a bit higher number of my video number, okay? But for people who are learning this for the first time, it may seem almost like Hebrew, the language of medieval Europe. Maybe I am not too good with history and geography, but that language almost does not exist today. So it may seem like Hebrew or Greek or Latin or other such foreign languages. As we know that C is also a language, it is a programming language. So I want to take it step by step. Every single letter that I type on the screen, every single letter, I want to make sure that you know why is Mr. Sukhbir typing that letter, and that only will make sure that the objective of this course is achieved. And the objective is to make sure that you first learn to think and then apply your thoughts to coding. Okay, so once again, for a quick recap, let's remove this part. We had written here a reminder of what not to do. Let's remove that, and this should be our code. Okay, let's revisit the code. Int start is equals to 1, which is our start position. Int end is our halting condition or halting milestone, whatever you want to type, because I took the example of walking down a street. So halting milestone, where your code should stop. And then we have a step variable, okay, and all are the type of integers. We all know what are integers: negative, positive, whole numbers, and the special number 0. We also spoke about the %d format specifier. Then we spoke about the loop. This is a special kind of a loop. It is called a for loop. Now a simple loop automates, sorry for the wrong word used, it automates a monotonous job. In the code that I removed, we wrote printf 5 times to print 5 numbers. So if you want to print a Google numbers, you have to have a code that has that same line 100 to the 100th power times, right? We showed you on the calculator that it is the exponent e to the 10 to the power 100, that is a Google. So you have to write those many number of lines or paste those many number of times, right? But here, no matter how many times you want to print from 1 to 100 or 1000 or whatever the number, whatever the arbitrary number you want to have as your end, you will always write a single line of printf directive. Understood? So to recap how to write the loop, a for loop has 3 statements inside it, 3 expressions inside it. It is not a hard and fast rule, but it is a convention to name them as initialization, test and halt condition, and the change. Alright, so we use the variable step as our primary loop variable. We make it equal to start. We define it as to what should be our halt condition, which is less than or equal to end, and we gave the compiler the directive to change the variable by the factor of +1, and then we simply print this variable, and that's it. That's the lesson for today. Thank you, and please like, share and subscribe if you like this way of teaching. I'm obviously sure that around 25 to 35% would be very irritated with my slow speed, but please bear with me. I'm trying my best to explain you every single character that I type, and once you have a grasp of the concepts and the constructs that I use in programming, we will definitely do more than 1 or more than 5 programs in a single video. And if you have any questions or any comments, please use the comment section. Have a nice day.